We're often interested in calculating the probability of at least one. So when we say at least one, what do we mean? At least one implies one or more. So if the least number is 1, then we could consider more than 1. So let's look at our example we've seen before of a couple having 3 children. Okay? So first let's consider the sample space for 3 children. Okay, so remember that was, we could have all 3 boys, or the first 2 boys and then a girl, or the girl could be the middle child, or the oldest child. Or we could have 1 boy and 2 girls, and there are 3 combinations of that. And finally, all girls. So we see the number in our sample space is 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 combinations when a couple has 3 children with regard to the gender. Okay, so in this case, now say that we want to find out or determine the probability that there's at least 1 girl among 3 children. So if we want probability at least 1 girl, well, let's look at the sample space for that. So the sample space for number of girls, what are our possibilities? Well, we could have no girls when we have 3 children, 1 girl, 2 girls, or 3 girls. And obviously that's the highest number we could reach because we only have 3 children. So there's our sample space. So the probability of it at least 1 girl, well, that would be the probability, we say that's 1 or more, okay? The probability of 1 or 2 or 3, right? That's what we mean. So or tells us what operation are we going to perform with our probabilities. Or is the addition rule. So let me rewrite that down here. Probability of 1 or 2 or 3. And now with the addition rule, remember we have to think, are these disjoint events? Is there any chance that these outcomes could overlap? Could a couple have 1 girl and 2 girls at the same time? No, they couldn't. So these are disjoint events. Therefore, we can write this as the probability of 1 plus the probability of 2 plus the probability of 3. Let me make a note here because these are disjoint events. They're mutually exclusive. Okay. Well, can we figure this out? Let's look back at our sample space. What's the probability that a couple has 3 children and one of them is a girl? Well, let's see. Here's a situation. Let me get another color. Here's an outcome where there's 1 girl. Here's an outcome with 1 girl, and here's an outcome with 1 girl. That's it. So there are 3 ways out of 8 possible outcomes to have 1 girl. Okay, how about probability of 2? Okay, 2 girls. Let's see. Here are 2 girls, 2 girls, 2 girls. Okay, so there are 3 ways out of 8 possible outcomes to end up with 2 girls. And finally, 3 girls. Well, there's only 1 way for that to happen, right? So 1 out of 8. So we can see that there's a 3 plus 3 plus 1, or 7 out of 8 probability that when a couple has 3 children, they have at least 1 girl. To have at least 1, you have 1, or you have 2, or you have 3. All of those represent at least 1. Okay, but what we find is that there is a much easier way to calculate this. In this example, it didn't take us that long to calculate 1 or 2 or 3, but what if we had way more than 3 girls? What if we were talking about some other situation where there were 50, 100, 200 in our sample space? And so the probability of at least one meant 1 or more, but more goes all the way up to 50 or 100 or 200. We wouldn't want to have to do this, right? This is quite tedious. So we need to think about something we've talked about before, which is complements. When we said 1 or 2 or 3, we're talking about this part of the sample space. And since we say or more, we really went all the way to the highest possible number from 1. Well, what's the only thing we're not counting? The probability of none. The probability of none would be the complement of at least 1. So we could have said the probability of at least 1 girl equals 1 minus the probability of the complement of that, which is no girls. And what's the probability of no girls? Well, there's only one way for that to have happened. Let's see if I can find a color. Right here. So that would be one way out of 8 possible outcomes. And you see how quickly we get to the same result. 7/8, 7/8. So you can, in this example, we just had 3 other outcomes to consider besides it for the at least 1. But again, this could be out of 15, 50, 100, 200, 300. We wouldn't want to have to do that many calculations. So it's very important to understand this, what we found here. And let's write that real clearly, what we found. What we found is when we need to find the probability of at least 1, it doesn't matter 1 what, at least 1 of whatever we're talking about, that's always going to be equal to 1 minus the probability of none. Okay, if you learn this, it's going to save you a lot of heartache in trying to calculate in the examples we'll see.